functions. So, here we go. Looks like I'm going to have to divide by 9. I think somebody already said that. And take the square root. What's important when I take the square root? Plus or minus the square root of x over 3. Right? And those are your implicit functions. If you type y equals root x over 3 into your calculator, it would be a function. And if you type in negative root x over 3, it would be a function. Were you in trouble?
No.
All right, find the range. Okay, so let's pause for a second. What does this look like? Remember, you are not going to have a calculator.
Parabola. Going down.
It's a parabola opening down. Perfect. Where is its vertex? Where is it situated? Negative 1, right. So here it is, and it opens down. Is everybody on board with that? Beautifully done. Beautifully. Now, what do we mean by range? Wise? Right? So tell me, what's the range of this thing? And I'm going to bracket it at 0 because I actually have a dot there. Is that okay with everybody?
Yes.
Remember, if you're using infinities, negative is always on the left. So if you're using negative infinity, it has to be on the left. Okay? All right, how about this one? What's going on here? It's a V, and it's a V that has been moved up 2. So its range, Dana says, is that. Is he right? Are we okay with that? You guys are awesome. Super. All right, is this thing even, odd, or neither? Okay, so wait a second. We have to test it. I'm going to put a y in there instead of an r of x. We have to test it. If it's even, it's going to have y-axis symmetry. And if it's odd, it's going to have origin symmetry. All right, so who remembers the test for y-axis? Plug in a negative for x. So if I come up here and plug in a negative for x, am I going to get the same equation as the original? No. So it's not even. What's the test for odd? Origin. Change both. So some of you got that confused with, so for origin, we change both sides. What do we do for y equals x? We switch y and x, yeah, you switch the variables. Here we change the sign on both. So negative y equals 2 negative x plus 1. Now be careful. If you're not thinking, you might say, oh yeah, those are the same. But they're not. Because when you divide by this negative 1, you get y equals 2x minus 1, which is not the same equation. So this is not even odd or it's not even or odd, so it is even. Bless you. Bless you. We okay? All right. Now we've got find f and g, so that f of g of x is 2x squared plus 8. So we need to find a function f and a function g. We did this the other day. So what should be going through your head is, what's going on in this problem? We have to square times by 2 and add 8. So there's three things that need to be done. And by the way, in that order, right? We have the square times by 2 and add 8 in that order. Would everybody agree? PEMDAS? Now you're going to build two functions that are going to make all that happen in that order. This matters because this tells me that the first things that are going to happen with G. Remember, composition works backwards. Okay, so what do you want G to do? Now wait. Is that the first thing I do in my list? What's the first thing has to, it's gotta be squared. So I can say f of x can be x squared. Or g of x can be x squared. So then f, if you choose that, which is fine, f has to do the other two things. So f has to take a number, times it by 2, and add 8. Remember, when you build your little functions, it's x. Because you're going to take this and plug it in here, and that's how you're going to get that answer. Now, what's another option? That's one option. What would be another one?
2x squared for g.
So g could be x squared times 2, and then f would be x plus 8. They're both right. There's no difference there, whichever way you want to do it. Is that okay with everybody? All right, let's look at this equation. What is the impact of the 2?
Up 2.
Moves the graph up 2. What is the impact of the 4?
That's the right one.
Moves the graph right 4. Is that okay with everybody? Easy enough? Okay, now we gotta do some function stuff here. So here's M, and N. And we're gonna do this. What's this? M of X minus N of X. What would that be?
3x squared plus 1 plus 2x minus
3x squared plus 1 minus 2x minus 3. And I'm going to go ahead and put that one in parentheses because I have to subtract the whole thing. So I'm going to have 3x squared plus 1 minus 2x plus 3. Stop right there. That's the answer. If I added right, that's the answer. Don't mess with this. Don't use the quadratic formula, don't factor it, don't do all that. You're not solving anything. What do the directions say?
5.
Find it. Right there it is, I found it. All right, what about the next one?
4.
Be careful. It would seem like maybe, but that's an open circle. And an open circle means composition. It means this. If that were a dot, like that, that would mean times. But when it's an open circle, that is just another way of writing composition. So this means take your M function and plug it into your N function. So my M function is right here. This is my M. And I'm going to plug it in right here. So M is going into N. So what will that be?
6x squared.
Yep, you're ahead of me here. But 2 times your M minus 3. So 6x squared minus 1, is that what you said? My job is to stand up here and babble. Your job is to ask questions if you have any. Do you have any questions?
We again, it's just finding.
Yep, you're done, yep, all you're doing is finding out. Okay, m of 4 minus n of 1. What does that mean?
Plugging 4 into the X.
Plug 4 into m, oh yeah. Please be careful when you do this. Do I times by 3 or square first? Square first. Square first. So this is going to be 16 times 3, which is 48 plus 1, 49. And then we'll do the same thing. We'll put 1. So that's going to be 2 times 1 minus 3, which is negative 1.
It's minus.
Well, I get negative 1 when I plug that in.
Yeah.
But since I'm subtracting, my answer's going to be 50. I'm subtracting n of 1. N of 1 is negative 1, so I'm subtracting negative 1, which is adding 1. Is that all right with everybody? All right, number 11 is kind of a catch-all. There could very well be problems with say things like this. Like on your quiz, you had one, name a BFF with N behavior. Now, what does this mean? This means as you go to the right, the picture goes up. As you go to the left, the picture still goes up. It looks like this, up, up. So what are the up, up functions? Absolute value, parabola, that would be the squaring function, right, or the quadratic function. Those are up, up. As opposed to a cube, which is up on this one, but down on that one, right? Okay, here's another one. Name a BFF whose domain is this. Name a BFF with that domain.
X
One that goes like that.
Square root of X.
Beautiful. That is,
What about ln? No.
now, ln, that one's a tricky one, Jake, because ln has an asymptote in 0. So ln's domain would be 0 to infinity, but not a bracket on 0. It would have to be open, right? It's tricky. Yeah. Name a BFF whose range is this.
X squared.
X squared. Parabola. Absolute value. All right, now I'm going to trick you. You want whose range is that?
Wait.
Somebody said it.
Exponential.
The exponential. Because the exponential has an asymptote at 0 and looks like that. Who said that? You're lost?
What?
Oh, no, you knew that answer.
Yeah.
Somebody said I'm so lost.
It was Jaden.
No, I said I was locked.
Locked? Okay, I hope you're locked. Because if we're lost, we haven't studied our BFFs enough, right? Yeah, we gotta know them. Gotta be able to answer questions like this. One more. Name a BFF that is not sine or cosine, but it's bounded above and below.
Logarithmic.
Logistic.
Yes,
The logistic is the one that has an asymptote here and an asymptote here, it squiggles up like this, right?
Yeah.
Yeah. All right, so when it says be able to recognize and sketch the BFFs, what that means is questions like this. Okay? So I'll ask you some characteristic and you will,
What's the one where it goes like up this way and down that way?
that's the reciprocal function. And the reciprocal function also has two asymptotes, just like this one, but they're perpendicular to each other.
So what would the range and like domain of that?
The domain and the range are both the same, and they're everything but zero. So this thing goes all the way down and all the way up, but it doesn't touch zero. So it would be negative infinity to zero, parentheses, union zero to infinity. And the same for the domain, because we go all the way this way and all the way that way, but we can't be zero. Okay? Now, an interesting characteristic of this is the entire curve is decreasing. When I draw this picture, which direction is my hand going? Down. Decreasing. And when I draw this piece of it, which direction is my hand going? Down. So the whole thing is decreasing. As opposed to this guy, the whole thing is increasing. But then you got the parabola, which is decreasing and then increasing.
Do you have questions on it? So when you're writing it out, it wouldn't be all reals, it would be like break at zero.
Yep.
Would there be decreasing and increasing questions on it? Does
Could be. See, what's the next one? We can do that with this picture that I drew. So let's do that with number 12. All right, so first of all, let's answer the questions that are there, and then we'll talk about increasing and decreasing. So I've got this random shape. And it looks like this. Okay, so here's some random shape that I drew. Name the absolute maximum. It doesn't have one. So absolute max, not applicable. Why?
Keep going.
Arrow, right? Name a local max.
Two.
A local max would be right here, isn't that?
0, 2.
The highest point is the top of the hill, so 0, 2. Now, sometimes they will ask for the x-coordinate, so that would be 0. Here we gave the whole point. An absolute minimum. Does this curve have an absolute minimum? It surely does. At 3, -3.
Why is there absolute?
Does it keep going down? Does it keep going down?
No.
What is it doing here? It's following its asymptote, so it's actually getting a little bit higher too, right? And does it have a local minimum?
Yes.
Same thing. So, locals are tops of hills, bottoms of valleys. Okay? Absolutes are the highest point you got, the lowest point you got. Alright? Now, question about, wait, now stop. Give me an interval, or all the intervals, where this curve is increasing.
-2 to 0.
It's increasing from here to here. Would everybody agree with that?
Wait, do you think we include negative?
So that is
Negative
0, from -2 to 0.
Wait,
So from here, this is -2, this is 0. That part of the graph is going up. Are there any other parts of the graph going up?
3, 2.
From 3 forever?
Yeah.
What? Remember, we're looking at x values now. Where am I decreasing?
Negative infinity
Decreasing from negative infinity to -2. And then I'm decreasing again from 0 to
3.
3. So Dana, does that, or somebody asked about that, does that answer your question about increasing, decreasing?
What, or do you have to, like, can you include -2 to -1 with that, but introducing stuff like that?
-2,
Or like, can you just say -2 to 0?
-2 to 0, because that whole part of the graph is going up.
Oh.
That whole stretch is going up. And this is all about going up or down. All right, let me go ahead and give you another sheet. We finished that one. I got 2 more that are here. And we will work on these and look at your homeworks and such next time. Okay? So I will see you all again on Monday, right? So on Monday, we will pick up with all this. Do some more review.
Is the back of part of it?
Everybody got papers? All right, have a wonderful day, everyone. Have a wonderful weekend. Oh, yes, please fill out my plate so I can grade papers.